is Calvin Bryce. I go to school at UW-Platteville. I expect to graduate next spring.
How come you guys don't have more confidence? It's always you expect to graduate.
They keep changing the program requirements.
I'm hoping to.
Yeah. My title here was a design engineer co-op, so I worked in the design drafting department, and I specifically reported to Mike Holland, as well as Mark Liebzeit over in Kiel. I would do some projects for him. So some of the things that I did on my co-op, I did a bunch of ECRs, some of the ones that Joel put in specifically. I did a lot of tool design for Mark. And then we recently got some new 3D printers over in the design department that I've been helping troubleshoot, set up, provide some consultation for. And then some of the things that I've designed, I've helped design some custom products. I've also worked on designing some gauges and fixtures, similar to what Joel did. And then one of the things that I developed was an ECR analytics spreadsheet. So we didn't have a very good overview on the flow of the ECRs moving through the drafting department, how many were actively in progress, how many were getting completed, and so forth. So I kind of helped analyze all of that and get a better overview. I've also worked on a calculator for designing a minimum inner radius of drawn parts. So we've got some specific features in some of our designs that we kind of made some modifications to every once in a while for some new parts that would come through. But we wouldn't really know until you actually started making it if it was possible to manufacture. It was all just kind of guessing. So I kind of helped design a process to eliminate a lot of that guesswork. And then I also worked on a bunch of macros for saving time, basically taking easily repeatable processes that required a lot of manual labor and just automating that. So, like I said, one of the things that I did a lot of while I was here was completing an engineering change request. So to this point, I've done over 170 engineering change requests. I plan to continue doing more until the end of summer. It's definitely helped bring that number down quite a bit. Some of those things that those ECRs involve is either redrawing components from outdated drawings, or designing new components, or just making simple corrections. One of the time savers that I worked on to help Austin out was a synergy data entry macro, and he kind of covered this quite a bit, but some of the benefits are that it reduces the chance of error when he's entering in some of the numbers, and it also saves a bunch of time. Then I also created for the drafting department another macro. So anytime that you go to save a drawing or a PDF from a drawing that is located in our legacy folder, it can take upwards of 3 to 5 minutes just to save that drawing, just because there are so many files in that folder. So what I did is I created a macro that just places a little button in SolidWorks. So you click on it, it'll save a PDF, or if there's a DXF, it'll save that all within just a few seconds because it's not even going through the trouble of opening up that folder. So that can save, over the course of a couple co-ops working every day using this macro, it'll save a lot of time. And then I also helped out, like I said a couple times, the Excel analytics. It just provides a much better overview on how we're doing as a whole in the drafting department in tackling ECRs. One of the first projects that I got to work on here at Vollrath was a heated dip tank. So we've got one over here at Sheboygan, but Kiel also needed one. So I was able to kind of take some of the designs for the old one and update it to meet some of the design requirements. And then I learned quite a bit along the way. So manufacturability drove a bunch of the design decisions. So I would come up with an idea, kind of bounce it off Mark and a few of the other guys over at Kiel, and then they would go, what about this, or what about this? Because in my mind, whatever I could come up with in SolidWorks would be the ideal way to do it. But when you actually go to start manufacturing it, you might find out filling your tank with insulating foam before you weld it all together might cause that foam to melt as soon as you start welding it. So I kind of had to think through the actual assembly manufacturing steps, as well as space requirements. So it was really helpful when I had to go pick out what type of heater I wanted to put in this tank. I kind of knew how much space I was working with because I had that model there in front of me. I learned a lot about the welding process. There's definitely some things, if I were to go back and redesign this, that I would do differently, as well as the design for assembly. When you're in school and you're learning how to design stuff, one of the things that I don't think is emphasized enough is just design stuff to actually manufacture it. It doesn't matter how good you can do it in SolidWorks. If you actually start to build it and it doesn't work, your design is useless. So make sure you put a lot of effort into thinking how through something is going to be manufactured. And then safety and ergonomics really came into play. With your operators, they're going to be spending a lot of time with this. So you want to make sure that stuff is at the right height, that they're not bending over too much, they're kind of keeping their range of motions within that nice safety. Another one of the things that I did is being over more in the other side of the room. I was located on the other side of the wall from drafting, actually, over more the marketing side. Well, there's quite a few people over there that once they knew kind of what my role was and what I was doing, they just stop by my desk and say, hey, can you help me out with this project? Can you help me out with this square? So I ended up doing a lot of inspection gauges for quality, templates, stuff like that. And then one of my big projects that I worked on that I'm pretty proud of is the Maysteel scanner top. So it's a product that we kind of helped where we received the drawing from the customer on what they wanted, and I was able to take that drawing, come up with some models and stuff for each of the different operations as well as tooling. So I'm kind of going to walk through that with you here quick. So we would start obviously with our blank, and then we would move into draw one. So I had to create a model for draw one, and then all of the tooling that we used to create draw one. From there we went into draw two, and then a couple of other operations until you reached the final piece. So it was really cool being able to start with just a simple customer drawing and walk through the entire process of how you're actually going to manufacture it, what different steps it needs to take. And obviously some of the things that we did in that process were more prototype designs, actually making sure that it would actually work. And then there was another final run through redesigning everything to make sure that it's going to be finalized for production. So it was really cool being able to work with all that. So I created a lot of drawings for this, for all of the tooling, for all of the models, and there was quite a few different design iterations, but I did have a bunch of help from Mark, which was helpful. And the first time that we started manufacturing these, the first time I went through press, there was 0 scraps, so it was really nice to know that all of my designs have been validated successfully, and that I was able to make some important contributions to the design.
How about the second and third time through the press?
Yep, they've been going through pretty successfully ever since then. So other than a few customer complaints about quality and stuff that we've been working on fixing, it's been going through really well. Everything's working as designed. So, summary of my co-op experience, I definitely improved my knowledge about the design and fabrication process. Going through school, you learn through all the different processes in manufacturing, but until you actually start applying them or seeing them applied, it's just kind of theoretical. So this is really where the rubber meets the road. You get to apply your knowledge and come away with a bunch of valuable stuff. I also got extensive experience with SolidWorks in itself. I primarily worked with a few other 3D modeling programs at previous jobs. So this was the first time I actually got to work with SolidWorks, which is the program that I used in school. And that was very beneficial, I thought. It's definitely something that I'll keep with me, and it's a valuable skill to my tool set. I also became proficient with the ECR process, working with different programs such as PEM, eMatrix, JDE, and then I worked with a bunch of really awesome people here at Vollrath. So I worked with design, product quality, and manufacturing engineers. I got to go out on the shop floor, see when stuff was wrong and what changes needed to be made. Sometimes it would just be a simple print correction. Sometimes it would be something had to be redrawn. So it was kind of cool to be able to go out, actually talk with people, interact with them, find out what their problems were, and then be able to use my knowledge to help solve that. And then I increased a bunch of confidence in my engineering skills. So, like I said, when you go through school, you kind of learn about all this stuff, but you walk away from a lot of these classes going, could I actually really be able to do this in the real world? So now that I've been here at Vollrath, I've had an opportunity to apply a lot of these skills and just know I'm capable of doing just about whatever is set before me. My primary skill set is that I'm an engineer and I can problem solve. So it doesn't matter if I know how to do something, as long as I learn or know how to learn to do something. That's what matters. Some of the benefits to Vollrath, like I said, I've completed over 170 ECRs. I've generated over 1,000 PDF drawings.